2 lines at a time. And last video we did parallel lines. This video we're going to do perpendicular lines. Not everybody remembers or knows what perpendicular lines are. They're 2 lines that do intersect. So that's the first way that they're unlike parallel. They cross. And not only do they cross, but at the point they cross, they're going to form 4 right angles or 90-degree angles. Not always the easiest to draw on the pen on the tablet here for the computer, but I'll do the best that I can. The 2 most common kinds of perpendicular lines, every time we draw a coordinate plane, we draw a pair of perpendicular lines. So that's why in the black on the left, all I have is the coordinate plane. If I were to look at the y-axis and talk about its slope, because it's a vertical line, the slope is undefined. Which basically means if a slope is undefined, it means that somewhere along the line we tried to divide by 0. For example, maybe the slope ended up being 1 over 0. You cannot divide anything by 0. It's okay to have a 0 on the top of a fraction, but you can't have 0 on the bottom of a fraction. Now, the line that would be perpendicular to it is the x-axis, which is a horizontal line. Horizontal lines and vertical lines are always perpendicular to one another. A horizontal line, like the x-axis, has a slope of 0, which could mean when we did rise over run, maybe we got 0 over 1. But the thing about these 2 slopes, they're slopes of lines that we already know are perpendicular. These 2 fractions are actually what are called reciprocals. Okay, reciprocals, you might remember from one of your earlier math classes, maybe 6th or 7th grade, are fractions that are basically inverted. The numerator of one is the denominator of the other, and then vice versa. The denominator of one is the numerator of the other. So these 2 fractions have been flipped around. Interchange the numerator and the denominator, and you have reciprocals of each other. When we're comparing the equations of perpendicular lines, like we compared the equations of parallel lines, we compared slopes and we compared y-intercepts. If 2 lines are going to be perpendicular, one requirement is that their slopes are reciprocals. So if one of the perpendicular lines has a slope that's 1/2, the other one has to have a slope that's 2. Not only that, though, in addition to that, you can see that I have over here the purple and the blue lines, not horizontal and not vertical. Now, this one has, the purple line has a slope of 2, and the blue line has a slope of -1/2. 2, if you remember, can be written as 2 over 1. So if I were to flip 2 over 1, the reciprocal of that would be 1 over 2. So these two slopes are reciprocals of each other, but the only difference is one is positive and one is negative. Is that necessary in order to have 2 lines that are perpendicular, 2 lines that create 90-degree angles? Well, I think it would be very difficult to draw 2 lines that both have positive slopes and have them cross at 90 degrees. You can try it. I'll try it here. Let's see. They both have to have a positive slope. This is going to be way random. And they have to cross to make a 90-degree angle. Well, those 2 lines both have positive slopes, and they do cross, but over here, this angle is much bigger than 90 degrees, and these 2 angles right here are much smaller than 90 degrees. I suppose I could try again. Let's try 2 negatives, 2 negative slopes. And I won't really make it, oops, let's not do that one. That one's almost going to be vertical if I drew that too much like that. I want to try to draw a line with a negative slope and make it so that it's perpendicular to the one I've already drawn. And as you can tell, I'm really struggling with that because it's not possible to do. Okay, in order to draw 2 lines that are perpendicular, one has to have a positive slope, one has to have a negative slope. And they have to be reciprocals of each other. So not only do perpendicular lines have slopes that are reciprocals? They have to be opposite reciprocals. So slopes of perpendicular lines must be opposite reciprocals. Okay, now in the last video on parallel lines, not only for parallel lines, in that case their slopes had to be the same, but we also had to compare the y-intercepts. If the y-intercepts were different, then we certainly had parallel lines. If the y-intercepts were the same, we do not have parallel lines. How about in perpendicular lines? Do perpendicular lines have to have different y-intercepts? The answer to that is no. I could have a perpendicular line to this purple line, and I'll draw it. Let's see. I'll use the lighter blue. Hopefully you'll see a difference. I already used that one. Let's use the darker blue. So this purple line has a slope of 2. What I want to do is make a line that's perpendicular to it that goes through that same y-intercept so that you can see. So whatever line that is has to have a slope of -1/2. Let's make a bigger dot. And we'll make it the dark blue. Boom. And boom. And when I connect them, try to do the best I can. Okay, they're going to create 90-degree angles, the purple and the dark blue, and so do the purple and the light blue. But this time these two have the same y-intercept. So, in summary then, we can say that perpendicular lines, their slopes have to be opposite reciprocals. Y-intercepts can be same or different. Okay? So you may want to add that to your notes. Slopes of perpendicular lines must be opposite and reciprocals. The y-intercepts can be the same or different. I'm going to clear this screen in a bit and we'll do a table that kind of summarizes. And if two lines aren't parallel and they're not perpendicular, then basically we just say, you know, they're two lines, they cross each other, but there's nothing special about them. So we'll talk about that too. Okay, hopefully you've had time to add that to your notes. If you didn't, you can always go back and rewatch the video. It was at about 8 minutes where those notes were completed. All right, so we want to make a table that kind of summarizes what we talked about with parallel and perpendicular lines. So we've got parallel, perpendicular, neither. Whoops. And we want to compare their slopes and their y-intercepts. Parallel lines have to have the same slope. Y-intercepts must be different. Perpendicular lines, their slopes have to be opposite, and I'm going to abbreviate, I hope that's okay, and reciprocals. I won't abbreviate that because that's a word I want you to get used to. The y-intercepts, they can be the same or different. It doesn't matter. And in order for two lines to be neither parallel or perpendicular, slopes, we don't want them to be the same. They have to be different from each other. Could they be opposite and reciprocals? No, they could not. If they're going to be opposite and reciprocals, then for certain they're going to be perpendicular. Can't be, whoops, opposite and reciprocals. What if they were opposite but not reciprocals? Fine. What if they were reciprocals but not opposite? Then they'd be neither. They can't be both opposite and reciprocals. Otherwise, it's going to throw you back up into the perpendicular section again. And the y-intercepts of lines that are neither perpendicular or parallel, they could be the same because they could end up being the same line. Over here. I suppose two lines that are neither parallel or perpendicular could also have the same slope. They could be the exact same line. Basically, what you're concerned with, first off, do your two equations fit the criteria for parallel? If not, do they fit the criteria for perpendicular? If not, then they must be neither. They must not they must cross or be the same line. And if they do cross, they don't create 90-degree angles. Okay, now again, if you need to get that in your notes, it was about at 10:50 that it was a complete chart. So if you need to look back to the video at about 10:50, you can do that. One other thing I want to add to this is comparing equations that are perpendicular lines. So these two equations. Okay, so we have these two equations. If we look at their slopes, one has a slope of 2, one has a slope of -1/2. They are opposites because one's positive and one's negative. And they are reciprocals. The two fractions are flipped around. So these two lines would be perpendicular lines. Okay, new set of equations. Some people will look at this and say, okay, first equation has a slope of 1/2. Second equation has a slope of -1/2. Those two slopes are opposites of each other. One's positive, one's negative. Yes, I would agree with that, but they're not reciprocals. So these two lines are not perpendicular. They're not parallel. Perpendicular, by the way, I'm sorry. This symbol right here, my line should be a little bit straighter up and down. This is a symbol shortcut way of writing perpendicular. This is a shortcut way to write parallel. There are two lines kind of running side by side. They look like maybe two L's next to each other, but sometimes I try to make them just a little bit longer so that you can see the difference. So these two lines would be neither parallel or perpendicular to each other. Okay, these two go together in your notes, and these two go together in your notes. And let's do maybe one more pair. Let's see, y equals 2x minus 3. For some reason, I'm stuck on 2's, which is fine. 1/2 x minus 3. So when we're looking at this pair, okay, so this third set of equations, the first one has a slope of 2. The second one has a slope of 1/2. Those two, the fractions are reciprocals. They're flipped around. But the fractions are not opposite. They must meet both requirements to be perpendicular. So they're not perpendicular. Slopes aren't the same, so they can't be parallel. Does it matter that the y-intercepts are the same? No, that doesn't indicate necessarily anything. It just means that they're going to cross at the same place on the y-axis.